All right, so for today, we're taking notes on functions, which is something we've already talked about, and it's just a machine or a mechanism that allows you to take an input and find an output. And so in the past, when I've said, I want you to solve the equation y equals 2x plus 3, and I want you to plug in 2 for x, that's a function. I gave you an input for x, and you solved it and found what y was, which is an output. So functions is just another way to label them and talk about them, but this is something that you've seen before. We just talked about domain and range of our polygons, and I want to look at how we can tell if something is a function on the graph and then incorporate what the domain and range is of that function, as well as if it's a function. So we're going to tie it together and then start moving further into functions. So let's start off with what a function is. A function is a relation where each number in the domain is paired with one number in the range. In the range. I had a misspelling right here. So it's a relation where each number in your domain or your x values is paired with one number in the range or your y values. So there's a way that you can figure out if this is true depending on what you're looking at. So if you've been given ordered pairs, you just need to make sure that none of your x values repeat. Because if your x values repeat, then it's not a function. So, for example, 2, 4, 3, 6, 2, 8, 4, 3. So if we know in this list of ordered pairs that the first number is our x value and the second number is our y value, if any of these x's repeat, it's not a function. And so since I have 2 repeating, and I have it here twice, then it's not going to be a function. Another way is to use the vertical line test. Now this is if you've been given a graph, and we're going to look at some examples down below. There's 6 of them. I'm going to do a few of them, and then I'm going to let you do the rest on your own. So you're going to use the vertical line test to see if it's a function or not. So if the x's don't repeat, it's a function. You're good to go. However, if they do repeat, it is not a function. So if I were to plot these points, the 2, 4 and the 2, 8 would both be sitting on the same x value, right? They would kind of be stacked on top of each other, just like you saw in that video we just watched. And so we know it can't be a function because if you were to put a vertical line over that, it would be touching more than 2 points at a time. And so we're going to look at some examples. So I'm going to do 11, 12, and 13, and then you guys need to do 14, 15, and 16 on your own. All you have to do is tell me if it's a function or if it's not a function. Just write, yes, it is a function. No, it is not a function. That is it for your answers. So for the vertical line test, I'd like to get something very skinny to use as my vertical line. So I'm going to use a tiny little gum wrapper. All right, so this is a vertical line. My line that I'm holding it vertically. And so while I hold it vertically, if it only touches 1 point at a time, it's a function. If it ends up touching more than one at a time, it's not a function. So you can either use the vertical line test as long as it passes, or you can actually look at these numbers. So we'll do both. If we use the vertical line test and I lay this on the graph and I start moving it across left to right, here it touches 1 point. Here it touches 1 point. Here it touches 2 at the exact same time, and then just 1, and then just 1. So because it touched 2 right here at the same time, this would not be a function. So I would write not a function. And again, if we want to list these points, let's list them. This coordinate point is 1, 2, 3, 1, 2. Negative 3, 2. This one is negative 1, 1, 2, 3. Negative 1, negative 3. This one is 1, -1. And this one is 1, 2. This one is 1, 2, 3, 1, 3, 1. And this one is 1, 2, 3, 4, 1, 2, 3, 4, -3. So when I look at the list of my numbers, do any of my x values repeat? Yes, right here. That's my giveaway. So I can look at it and use the vertical line test to see if these points that are plotted are going to sit on top of each other, and if they do, then it's not a function. Or if you're more comfortable, you can list out the ordered pairs and see if any of your x's repeat. So I'm going to do, again, over here, the vertical line test. Take a vertical line, you can use your pencil if you'd like, and run through that graph from the left to the right. Like I've always told you guys, this is how we read graphs. And see if your vertical line touches more than one point at a time. This one doesn't. It doesn't touch more than one at a time. So yes, it's a function. And again, let's list these points out. This is -1, 2, 3, -1, 2, 3. This one is -2, +1. This one is 1, 1, 2, 3, -3. And this one is 1, 2, 3, 4, 5, 1, 2, 5, 2. None of those x's are the same or repeating, so that's how I know that it's a function. And again, you can do the same thing for these lines that are down here. I know that you guys are going to do those on your own. But for these lines, you see how there's not many dots in between? That's because it covers every single little tiny point that there is. So you don't have to list these out because that would be a lot of points to be listing. And so when you have lines like this, it's actually much easier to use the vertical line test and say, is this a function or is this not a function? And so if, when you move from left to right, if it is touching this line, it can only touch one part of that line at a time. If it starts to touch two places on the line at the same time, it's not a function. So you would have to tell me what you think 14 is. For 15, if I go left to right, it starts to touch the line here. And then is it ever touching more than one place on that line? And then for 16, same thing. Is there ever a point where my vertical line that's cutting through this graph is touching the line in more than one spot at a time? Again, remember the video that we just watched. And so if I go up here and I look at this last set of points, am I touching more than one point at the same time? And I believe I am right here. So I would say not a function. And just to be clear, I'm going to plot these for you since these are just points and it's not a line. So -3, 2, -2, -3, 1. Oh gosh, I'm so sorry. 1, -2, 3, 0, and 3, 3. So right there they repeat, and that's where they also sit on top of each other. So that causes it to be not a function. So when you are plotting points, and soon we will be plotting functions, you have to make sure that there's not a point on your graph where they're sitting on top of each other, essentially. So you guys need to do these bottom three on your own. Whether or not they are a function, you just write yes or no, they are not a function. And then the second page of your notebook is going to be on your own. You're going to be deciding whether or not this line that has been drawn is a function, first of all, yes or no, but also what is the domain interval and what is the range interval. So we're going to be combining a domain and range and our knowledge of functions and how to tell if it's a function together on this page. And there are 8 problems. So I will do the first 2 for you, and then you need to do the other 6 on your own. So this is going to be titled Domain and Range. So there's one thing that I want you to be aware of when you're doing the domain and range intervals and you have a function that's been graphed. If one end of your line has an arrow on it, that represents that this line continues going forever and it does not stop. If your line has 2 endpoints, then that means that this is as long as this line is ever going to be. It is just sectioned right here and here. So when you write the interval of this function, it's going to be very different than one that has an arrow on it. So these arrows are important for us, and we need to make sure that we are writing the answers to our domain and range intervals properly based on what we're seeing. So remember our notation. So I'm going to write my domain, and then I think I'm going to write my range in green, just because I like to color code things. So if I'm looking at the domain of this function, I am looking on the x-axis, right? Domain is x-axis. So on this x-axis, before I write that it's in between two numbers, let me just look at my graph because I don't want to write the wrong thing. So it looks to me like this line is between -3 on the x-axis and I can't say a number over here, right? Because technically this line keeps going. So from the left to the right, it looks to me like the lowest number that this line will get to is -3 on the x-axis. And since this line is going to continue going, it's going to hit every number that there is above -3. Granted, it is going down, but as we go from left to right, this line is still going. It's going to continue crossing all these x values. So what I'm actually going to write for my domain is that my x values are anything greater than or equal to -3, right? So anything greater than or equal to -3. So as long as it's from -3 up, it's included. So I actually don't have to write a number on the left and a number on the right because it's not in the middle of two numbers. There's one dot, which means it's going to keep going on the other side. So the other side doesn't have to have anything. So what I like to remember as my little hint, and you can write it, we'll write it right here. One number, one dot. Two numbers, two dots. So when your graph has one dot, that means that your domain and your range is going to have just one number in the answer. When you have an example like number 4 and you have two dots, then your answer should have two numbers as well in the middle of those. So that's kind of my hint that I use to remember. Now, if we look at the range of this, so the range is talking about my y-axis, so all these values on the y-axis. What's the highest that this line touches? And it looks like the dot goes all the way up to 2 on the y-axis. Do you see 2? And the dot's right there. And then as we go down, this line is cutting through all of these numbers, and this line would keep going, which means it would keep going down the y-axis as well. So for my range, my y value is anything less than or equal to 2, because from 2, it cuts through 1 and 0 and -1 and -2 and -3. Because again, if I shaded this, and I just kept on going, do you see how everything less than 2 is being shaded on my y-axis for my range? And then for domain, I shaded this way and I went that way, like the arrow is telling me, it's everything greater than -3. So we can see which way it's going based on the arrow, and we can shade if we need to. I'm actually going to do number 4 to help you guys out because these two are different types of examples, that way that you have an example of each. So let's look at the domain and range for number 4. Since there are two dots, I know that I'm going to have two numbers. So my domain and then my range. So let's look over here at these two dots. If I were to follow these dots up to the x-axis, which is where the domain is, and shade that way, it's actually all the numbers between -3 and 4, you see? And so since there's two dots, my answer should have two numbers. The domain is talking about the x-axis. We got to have those symbols to put it in the middle. And my two numbers on the outside are -3 and +4. Do you guys remember doing this in class? So again, the smallest number goes on the left, the bigger number goes on the right. You literally write it in the order that you see it. You should see the least number on the left and the bigger number on the right. Now for the range, I need to take these dots and run it over until I run into my y-axis. So from this dot over to the y-axis and this dot over to the y-axis, the only space that it's taken up is right here. That's as low and high as it goes on the y-axis if I follow those dots over. So the lowest point on the y-axis is -3 all the way up to -2. So since it's in between two numbers, we put the y value in the middle. My lowest number is -3. My highest number is -2. So it's from -3 to -2 on the y-axis, and it's from -3 to 4 on the x-axis. That's where you'll find that line. So again, if there's two dots, your answer should have two numbers. If it's just one dot and there's an arrow going on, then it's just going to have one number in the answer. And the number is going to be where that dot is. So the x value of that dot is -3. The y value of that dot is 2. -3, 2 is that dot. And that's where everything stems from. Everything greater than -3 and everything less than -2. So this is your assignment for today, along with the 3 from the page before. So you need to upload your notes and make sure when you upload your notes that the rest of the problems are completely filled out. Good luck with that today. We're going to continue talking about that throughout this week.